Hello, good afternoon. Welcome to the session. I hope you had a good lunch, and I hope you all got a chance to see the keynote this morning. That was pretty exciting. Are you excited? I hope you are. We got, yeah? All right. We got Silverlight 3 beta coming out. We got IE8. We got IIS Media Services. We got so many great things. And today, at this session, we're going to be talking about Microsoft Silverlight Media end-to-end. So the goal of the session today is really, I want to enable you to deliver a great user experience using Microsoft Silverlight. And there are three essential things you need to do in order to be able to deliver such an experience. The first thing is to actually create your application. The second thing you need to do is to create the content. And then third, final thing, obviously, is to deliver that content. Now, I'm going to show you three examples today that basically will illustrate how you can do this. The first example is what I would call the easy example. We're going to use Expression Encoder as the tool to create both the user experience and the content. And this is, in my opinion, the fastest path that you can take today to delivering a Silverlight media experience. The second example we're going to look at is one of CTV HD, a website that CTV launched this week. And we're going to use this example of something where they took a base experience, an out-of-the-box experience, and then further customized it to build on top of it. And the final example we're going to look at today is a website built by Origin Digital called Accenture Business TV, in which they essentially built the whole experience from scratch. They didn't use any out-of-the-box things. They basically built the entire workflow from scratch. And this is an example of probably the most advanced workflow that you can have. And obviously, we're going to be talking about a lot of the media features that Silverlight 2 already has today. But we're also going to talk about some of the media features that are coming up in Silverlight 3. If you were at the keynote this morning, then you probably already heard about some of these media features. But I will also be talking about them here today. I highly encourage you that you check out some of these other sessions that we have here at MIX. So my session today is really sort of a high-level session. There's a lot to cover, so we're going to cover both content creation, user application creation, and the content delivery. But if you'd like to really find out about any of these things in more detail, I encourage you to check out these other sessions. James Clark is presenting this afternoon about content creation in more depth. John Bocciaro will be presenting tomorrow about the content delivery using IIS, IIS Media Services. And finally, Nick Brookins from Akamai is going to be talking about delivering ads to a Silverlight player on Friday. So without any further ado, I will start by showing you the three demos that I mentioned earlier. So the first demo that I want to show you today is basically one of an out-of-the-box experience that you can get from the Expression Encoder. And in this particular case, we're going to be looking at a template that we call the User Experience Simulator template for smooth streaming that enables you to sort of simulate those network conditions, varying network conditions that you really want to be testing with when you're deploying a smooth streaming experience. I'll talk more about how you actually set up this template and coding job a little bit later, but let's just take a look at the player first. So here we have a very simple Silverlight player that has some basic user controls. Here in the bottom, you can see you have your basic transport controls, your pause, stop, play, and so on. There's your volume control right there. And then, for example, if we go to full screen experience, you can see that these controls are still there, but after a while, they actually go away. So it's a very nice experience where transport controls persist in full screen mode. They come back if we move the mouse. If we exit the full screen experience, there it is. The seek bar is also enabled. These are all things that you would obviously expect from a media player. This is nothing revolutionary. I'm not showing you anything you haven't seen before. But these are things that you can get out of the box today with just using Expression Encoder and nothing else. The cool thing about this particular template that we're using here is that this is what we call sometimes we call it the graphing player, sometimes we refer to it as the user experience simulator. And this allows you, because this player has built-in smooth streaming support, and if you saw the keynote this morning, you saw the announcement about smooth streaming. But this player in particular has smooth streaming support built in, so that you can actually see what bitrate is being used, what bitrate is being downloaded and played. So as I seek, you can notice, for example, that Sorry about that. So as I seek, you can see that we start seeking by actually seeking to the lowest bit rate, and then as the network conditions improve, basically the bit rate starts climbing back up. And then this template also allows you to basically further throttle that bit rate. So if you seek again, the next time around, we're not going to, the bit rate will start climbing up, but it will not climb any further than the 1.5 megabits that I selected up here as the maximum bit rate. So I'll talk more about smooth streaming, a little bit more detail a little bit later. But right now, I just want you to focus this as a player experience, as an out-of-the-box player experience you can get today with Expression Encoder. So the second demo I want to show you is the website that CTV launched this week called CTV HD. And this is a website they launched for their on-demand, some of their on-demand content. So in this particular case, they are offering some of their programming in HD using smooth streaming. And if we go, for example, and launch one of these episodes, the first thing you'll notice after the player initializes is they start by delivering an ad. And you notice that as they deliver this ad, first of all, you might have noticed the quality started a little bit low, that went up. That's because of smooth streaming. The second thing you might notice is that there's no user controls actually available in the player. That's because this is an ad, and they don't want you to skip the ad, right? This is their monetization opportunity right here. When the ad finishes, they're going to basically then continue on with the actual main feature. And as the main feature starts playing, the user controls would then appear on the player. So this is, once again, nothing revolutionary, nothing you haven't seen before. But this is a player where they essentially took an existing player infrastructure and then customized it and built on top of it. So you can see now that we have a regular user experience that you would expect from a player. And this is, once again, using smooth streaming. So as I seek, you see that it's instantaneous seeking. And this is not running locally off my laptop or anything like that, or off of some network here we have at MIX. This is actually coming directly from Akamai CDN server. So this is actually running live right now. Not as live broadcast, I just mean actually working for real. So this is the CTV website, and this is an example of what I would consider an intermediate workflow. And so the final demo I want to show you today before we launch into the details of all this and explain how it's all done is this is a website that was built by Origin Digital. And actually, I'm sorry, let me launch a local version of this just in case, because it's not a public website yet. There we go. So this is a website that they built called Accenture Business TV. And this is a typical business portal type of website that features some videos. So for example, if we now go and click on one of these videos, we'll start playing back. And notice that, for example, there's this very rich seek bar that they developed down here that has markers built in that allows you to seek to certain key points in the presentation that's being delivered. So for example, I can go and I can seek to a particular marker that they set in their video. So that's pretty nice. So a rich seek bar. They have this ability also, for example, to add tags. So at any point in the presentation, you want to say, you know what, I want to add my own tag here. They actually have an interface to do that as well. And that will get marked. And of course, next time somebody plays that, they will see your tag in there, your bookmark. They'll be able to pull it up as well. So we'll come back to this demo a little bit later because there's actually some more details in here that are very interesting, but I don't want you to forget them. So we'll come back to it later. So let's go back to the presentation now. And now that you've seen these three demos, let's talk about a little bit about what does it take for you to actually build these kind of experiences. So when we talk about the Silverlight media ecosystem, in its most simplest form, the Silverlight media ecosystem consists of creation, encoding, and delivery. In this first example that we looked at, where we had Expression Encoder, we used Expression Encoder 2 to both create the user experience and to encode the content. When it comes to delivery of content, we can use Windows Media Services or IIS, for example, to deliver the content. And then, of course, to consume that content, we use Silverlight as the actual user experience. So the first step we're going to focus on is the actual creation. So we're going to look at Expression Encoder and what you can do with Expression Encoder. So Expression Encoder 2 is what I refer to as the fastest path to Silverlight. It's really a one-stop shop for if you want to just deploy a player and some content online. So Microsoft Expression Encoder 2 supports encoding to formats supported by Silverlight, which is Windows Media and smooth streaming. It also includes player templates that allow you to basically create these player applications very easily, just with one click. No coding necessary if you are not a developer, even if you're not a designer. If you just want to basically put a player on the website that plays some video, this is the way to do it. Another cool feature that's a part of Expression Encoder is that it also will publish directly to IIS 7. So if you have an account, like for example with something like Silverlight streaming website, you can actually publish directly to that service from Expression Encoder. Expression Encoder started out originally as an on-demand and live encoding tool, and that's really its primary purpose, is really to ingest media in a number of different formats. So that could be QuickTime, that could be MP4 files, that could be AVIs, Windows Media files, and then transcode them to some format that is compatible with Silverlight and that is suitable for the web. Other features that Expression Encoder supports are just simple cuts. If you need to basically just trim parts of your video or do simple cuts within the video, you can do that within Expression Encoder. If you need to add a trailer and a leader, you can actually do that immediately there. If you want to integrate ads into your presentation as well, you can put markers into the streams directly in Expression Encoder, basically mark your endpoints, and then later on at runtime actually insert ads at those points. There's other rich metadata that Expression Encoder supports. So you can, for example, add any information about the media presentation that you're playing right now. You can add chapter marks. You can add captions, subtitles, and have those show up later in the player as well. And then I mentioned earlier that it supports also direct web app publishing to web services. Now, with Expression Encoder Service Pack 1, which we released a few months ago, we added support for encoding to the smooth streaming format, particularly for the smooth streaming on-demand format. Live encoding is not in there yet. So the other thing that we added in Expression Encoder 2 Service Pack 1 are Silverlight 2-based templates, player templates, that have smooth streaming support already built into them. And we'll talk more now about these templates as well. And another thing that we made available with Expression Encoder is an SDK. So, for example, if you're building an automated workflow where you don't actually want to go and manually set up each encoding job and actually bring up the UI, you can actually invoke this SDK from your code. So you can build your own C# application that goes and calls into the Expression Encoder and does all this stuff automatically. I mentioned that in Service Pack 1 of Expression Encoder, it supports encoding to smooth streaming. If you're curious about how to actually encode to smooth streaming, it's very easy. So all you need is the retail version of Expression Encoder 2. You need Service Pack 1. And then if you want to encode to smooth streaming, you basically just need to make sure that you set the output mode to smooth streaming, to IS smooth streaming, and that's it. There's some other options in there that you might need to configure, but the Expression Encoder will let you know what those are. I mentioned the templates. They're really a key part of Expression Encoder 2. Is the ability to generate these out-of-box player experiences. This is an example of the default Silverlight 2 player template that you see on the screen. It's a fully featured player that has really all the features that you would expect from a media player. So it's got transport controls, volume controls, seat controls, all those show up on the screen. When you go to full screen, those are still present. They're overlaid over the video itself. They go away if you're basically idle and don't do anything. If you have captions, if you added captions to your content during the encoding part, those captions will show up in the player itself as well. If you basically want to define multiple items to play, then you can also bring up playlists. If you marked chapters, if you put chapter marks in your content during the encoding phase, then you can then access those chapters easily from the Silverlight player template as well. And finally, the IIS smooth streaming support that I mentioned earlier, that's built into this player template. If you want to create a player using Expression Encoder 2, that is also very easy. As you're setting up your job, and I'll show a demo of this in just a few seconds, but as you're creating your job, basically all you have to do is just select a template in the job output panel, and when you select, for example, the Silverlight 2 default template, you actually get a little preview of it shown on the screen, so you know that that's what it's going to look like when you actually encode your content. And after you encode the content, Expression Encoder will launch this template in a browser and play your content back in it, so you can immediately see what it's going to look like. So that's it. That's really how easy it is. If you basically want to deploy some content to our website today using Silverlight, it could be that easy. But you don't need to stop there, right? You can actually use the templates that we ship in Expression Encoder 2 Service Pack 1 as just a base player and develop on top of that. We don't only provide the binary code, we actually provide the source code as well of all these templates. These are released under Microsoft public shared source license. So they're free to use, modify, deploy. You can do whatever you want with them. And the way they're designed is in a very modular way, so that the actual UI component is separate from the player engine component, which is separate from the adaptive streaming, the smooth streaming component. So for example, if you're building your own player project and you just want the smooth streaming functionality, but you don't actually care about the look and the feel of the Expression Encoder's templates, you can grab just a smooth streaming component and drag it into your application and use it as is. No further work necessary. So let me show you a very quick demo of basically how to build an application. Sorry about that. There we go. How to build an application using Expression Encoder. So the first step would be to go and import some media into your Expression Encoder. So we see the media show up there. We go and configure some encoding settings here. So for example, for this, I'm choosing to encode 512 by 384 at a megabit. And we can go and then further, even if we want to enable like the interlacing and other pre-processing effects, we can enable those down there. If you're a codec guru and you really care deeply about quality, there's advanced codec settings, a lot of them that you can go and configure. And then, for example, if you want to add some metadata, for example, here I added some chapter points for this particular clip. So this is a Silverlight little promo ad. And I added some chapter marks in here. I mark my start. I mark a section where we, in this clip, show some websites. And I mark sort of like the end of the final section of that clip. And I also ask it to generate thumbnails for all those chapter marks. And then the final thing I did here is actually I inserted some captions in here as well. So at certain parts of the video, I specify the caption and gave it some text that I wanted to display during playback. And then finally, as the last step, I picked a Silverlight 2 template that I wanted to use as my player template when I actually finish the encoding. So I'm going to go ahead and click encode, and because I've already have encoded this before, it doesn't need to re-encode it again, so it's just immediately going to launch this piece of content. So here we have that piece of video playing that I picked earlier. So now the first thing you might see is that in a few seconds you might see an actual, you'll see a caption show up below the actual screen. And in just a second now. So there we go. So it says these are the Golden Globes, because it's just showing the section about the Golden Globes. And so the captions I inserted automatically show up. If I want to disable those, I can click on this CC, closed captioning button down here to disable that. If I want to go full screen, easy to go full screen. The controls are still there. If I don't do anything, they go away. The captions, notice, are still being displayed. And also remember I inserted some chapter marks into that clip. So for example, if I click this button here, it shows those chapter marks along with the thumbnails. If I want to go directly to the end of this presentation, I just click on that, and there we are. If I want to add multiple items in the playlist, there's a playlist button here that will bring up the full playlist. So it's a pretty full-featured player here. So this is the kind of experience that you can get immediately out of the box. So now, the second component that I mentioned earlier, I said there's three things you need to do to deliver an experience. The first one is to create an application. Second one is to create the content. We just did that. Third one was to deliver the content. So how do we deliver the content? We have multiple options today to deliver content to Silverlight Media, to a Silverlight player, I'm sorry. The first one is traditional streaming. Traditional streaming is something that if you've dealt with Windows Media in the past, if you've done any sort of streaming with Windows Media, the Silverlight basically in the last decade, you have experience with traditional streaming. The second option is progressive download from a web server. And the third option you have today with IIS7 with IIS Media Services is smooth streaming. And I'll go into now details about what are the differences between these three different methods of media delivery. So one of the first ones that I mentioned, actually the second one I mentioned, is progressive download. Progressive download is essentially just plain HTTP file download. So just like when you go to a website and you download, say, a Word document to a computer, in the same manner, in the same way, you can actually download media to your computer. And that's what progressive download is. You basically put a file, a media file on the web server, and you deliver it to the client. So the way it works is that the file in its entirety gets downloaded immediately to the client. As it's being delivered from the server to the server sends this file down to the client as fast as it can. Now, if the user's connection is 3 megabits, then that's the speed at which the server will send this file down to the client. The second form that I mentioned of media delivery is traditional streaming. With traditional streaming, the server actually keeps track of the state that the client is in. So the client establishes a connection with the server and then issues commands to the server that says, here I am, I'm a client, I'm capable of playing back this media. Please play back this media. At some point later on, it might say, I want to pause this media, or I want to seek to a different point, or I want to entirely disconnect. And this is basically just one session during which the server keeps track of which state is the client in. As the client basically requests, please can I play back this media, the server says, sure, here you go, and starts sending the media in the form of very small packets down to the client. These packets are sent at a constant bit rate, so that, for example, if you have the content encoded at, for example, 1.5 megabits per second, that is the rate at which the server is going to send the media down to the client. Even if the client has 100 megabits available, it doesn't matter. The media will get sent down at 1.5 megabits per second because that's the encoded rate of the media. So it's always being delivered essentially in real time. If you're interested in delivering media to Silverlight today using traditional streaming, your best option for this is Windows Media Services 2008. If you've used Windows Media Services 9 and Server 2003, you might be asking yourself, well, why should I bother with Windows Media Services 2008? Isn't it the same thing? It has the same functionality, yes. It's basically still traditional streaming. It's a free download for really all editions of Windows Media Service 2008, all SKUs from the lowest, cheapest one all to the most complex, most expensive one. But really, one of the biggest benefits in upgrading to 2008 is that it offers you double the scalability compared to Windows Media Services 9 that was back in Server 2003. So you can actually double your throughput. So that's pretty important. The other cool option is that if you do like headless server installs, where you basically just do a core install of Server 2008, you can install Windows Media Services on that as well, so that gives you a reduced footprint. I'm sorry. And finally, there's a plugin that now is integrated into Windows Media Services. This is the Cache Proxy plugin that allows you to distribute the load across your network. So instead of having all the clients connect to the origin server, you can now distribute basically that content across several servers and reduce the load on the origin. IIS Media Services is something that we just announced today. Officially, we announced IIS Media Services for IIS7. And these IIS Media Services are basically they're extensions for IIS7 that really enhance the delivery of media using IIS. IIS is a web server that, typically, traditionally is used to deliver, really any data format. And some of it is media, but the IIS Media Services really focus on enhancing that delivery of media using IIS. You can go and download IIS Media Services already today. If you go to iis.net/media, you can go and download them today. There's several components that are part of IIS Media Services. There are two components in there that essentially enable playback of existing content using progressive download. One is called bitrate throttling. What is bitrate throttling? I mentioned earlier that with progressive download, for example, when you deliver a file using progressive download to a Silverlight client, the server is going to ordinarily send that file as quickly as it possibly can, as quickly as the network connection allows to the client. Now, that could seem like a good idea, right? But there are actually situations in which that's not such a good idea. And one is when you're actually looking to save bandwidth, as most content providers do, right? Not everybody wants to, I mean, you're paying basically by the gigabyte, so you're not going to waste bandwidth unnecessarily. How do you waste bandwidth in the case of progressive download? Well, let's say that you go to, for example, YouTube, and you go and you select the video that you want to watch, and you start watching that video. Now, that video is being delivered using progressive download on YouTube. So it's being sent to your computer as fast as it can. And let's say that that video we're talking about is about 2 minutes in length. Well, you start watching the video, and as you're watching, it's being downloaded to your machine. Now, about 15 seconds into the video, you go, you know what, this is not so great. Whoever recommended this to me. And you decide that you don't want to watch any more of that video. But the trouble is, you got such a fast connection, those 15 seconds that you're watching the video, the whole 2 minutes of it downloaded to your computer. Well, you just wasted not just your bandwidth, but the content provider's bandwidth. So as a cost-saving measure, we have this feature in IS Media Services called bill rate throttling to address this issue, where essentially if you want to deliver your media using progressive download, but you don't want to waste too much bandwidth, you can actually tell IIS to deliver the media, to deliver the content to the client only at the speed at which it is encoded at. So it acts more like streaming, where it's actually being delivered at the encoded bill rate, but it's still progressive download. So it's a pretty cool feature. And then the other feature that's a part of IS Media Services that really is also about enhancing progressive download is web playlists that allows you to monetize, for example, in ad integration scenarios where you want to deliver some content, but you don't want people on the client side to know where that content exactly is coming from, so they can't deep link to it. So this feature allows you to basically obfuscate the URLs that the actual media content is coming from. So let's look at some of the pros and cons of streaming versus progressive download. So traditional streaming is great in that respect that it gives you very easy tracking of usage. So basically, because you're delivering at a constant rate and because you know exactly when the session starts and stops, you know exactly how much content the users have consumed. So it's great for that. The trouble with traditional streaming is that the web today is really built primarily for HTTP delivery. And there's edge networks, there are caches, there's just tons of caches out there. They're primarily HTTP caches. Traditional streaming cannot take advantage of this infrastructure. And so that's a problem. That means that basically if you want to really improve the scalability of your traditional streaming delivery, you have to go and deploy these specialized caches for whatever your streaming method is. So that's a big minus there. Progressive download, on the other hand, doesn't have these problems, right? Progressive download can take advantage of any web HTTP cache on the web. So it's great for that. But then on the other problem with progressive download, the problem with progressive download is that it's very difficult to track the usage, right? So client usage, difficult to track, and then we also run into this bandwidth wasting issue, unless, of course, you're using bill rate throttling in IIS-7. But otherwise, you run into this bandwidth wasting issue. So in order to mitigate some of these downsides of these two delivery methods, but at the same time take advantage of their benefits and their advantages, we came up with smooth streaming, which is really the best of both approaches. It's the best of both worlds. It takes the best of traditional streaming, combines with the best of progressive download. Smooth streaming is a feature that's also in IS Media Services. So we announced today the availability of IS Media Services with smooth streaming, both for on-demand and live. And the beta of smooth streaming is now available online. You can go and download that and play with that as well. The recommended way to install it, I encourage you, is to actually grab the web platform installer, which then gives you the opportunity to install not just IS Media Services, but any other server component that you need as a part of your web platform. So we talked a lot about smooth streaming. Now, maybe you went to the keynote this morning, maybe you didn't, but it seems like we should talk a little bit about, okay, what exactly is smooth streaming? I keep talking about it, but what exactly is it? Excuse me. So smooth streaming is Microsoft's implementation of HTTP-based adaptive streaming. What it is, it's really a hybrid media delivery method. It's called streaming, but it's not really streaming. It's not traditional streaming. It acts like traditional streaming, or what in fact it is, it's just a series of progressive downloads. So what it means that because it's a series of progressive downloads, it can take advantage of the existing HTTP infrastructure on the web. So it can basically, it's fully cacheable. It can take advantage of any existing HTTP caches out there. But it actually works like streaming. And the really cool part about it is that on the client side, the client can seamlessly and in real time switch between different bit rates and different video quality levels in response to the changing conditions of the network bandwidth and CPU resources. So basically, as the network bandwidth of the client goes up or down, it can then throttle back and choose basically lower quality or higher quality. And if the CPU resources go up or down, so for example, if you start some CPU-intensive job or your machine while you're watching a video and there's not enough CPU cycles left to basically decode the video at full frame rate, it's actually smart enough to go pick a lower bit rate, which is going to basically take less CPU cycles to decode and play back. So how exactly does smooth streaming work? So we saw how progressive download works, where basically the whole file is downloaded at once. We saw how traditional streaming work, where the content is sent in small packets down to the client. So with smooth streaming, we kind of combine those two concepts. Basically, the client starts by requesting a time slice, a time segment from the server. And it says, hi, server, can I please have this chunk of video between 1 minute and 2 seconds and 1 minute and 4 seconds? And the server responds back by looking into this large contiguous file that it has on disk and figures out where exactly is that time slice in the file. So it finds where it is in the file and grabs just that fragment of the file and says, all right, here you go, client. I'm going to send you basically this piece of video that's only 2 seconds in length. And it sends it down the pipe using just, like I said, HTTP progressive download. Now, somewhere along this route between server and client, it might pass a web cache. That web cache sees that this byte stream that the server just sent down to the client matches the HTTP request that the client sent and goes, huh, this looks like any other file that's being sent through the network. I can cache this. And then, of course, it proceeds down to the client. So then after the client requested like this 2-second segment, the next thing it's going to do is going to request the next 2-second segment. So now it wants, give me video at 1:06. And so the server basically just repeats this step after step. And as these chunks, these fragments of the video are coming down in 2-second fragments, the client is essentially assembling a seamless stream of these fragments and playing them back as they're coming in. So it's a pretty basic system. The cool thing about the caching part is that now if there's another client in the network that now asks for those same video fragments, they're not going to go all the way back to the origin server to ask for them. The cache is going to go, oh, I've seen this HTTP request before. I have these files cached. Here you go. So that cache is probably much closer to the client than the origin server is. So that enables basically, it hugely improves the scalability of this delivery solution. So the other part of smooth streaming is the adaptive part, where we actually change the quality of the video in real time. And the way we accomplish this is that we encode the video of multiple bit rates. And as we encode the video of multiple bit rates, we make sure that all the keyframes in that video are actually perfectly temporally aligned between all the bit rates. So that exactly basically, 60 frames into the video look exactly the same in all of those encoded bit rates. So we might have a range of bit rates in this example going, starting at 300K and then, a few interim bit rates going all the way up to, say, 2.4 megabits per second. So on the client side, there's basically this heuristics model that determines, which bit rate is it going to seek to, is it going to request at which point in time. As it starts off by, when you start playback, by requesting the lowest bit rate chunk. So it asks for the 300K first. The 300K comes in, and as it's being downloaded to the client can time how long it took to download that chunk. So based on how long it took to download, they can now figure out, okay, I think I have more bandwidth available than just 300K. So next thing it's going to do, it's going to request a slightly higher bit rate chunk. Maybe it's a 600K chunk, and it's going to request that. Once again, it's going to download, it's going to time how long it takes for that download, and go, okay, I think I have more than 600K. And so it's going to keep going through this process, basically. Now, at some point later on, as these chunks are being downloaded, your network conditions might actually deteriorate. Maybe somebody in your living room just suddenly started downloading a huge file, so they're taking up a huge part of your bandwidth. And your bandwidth goes down, so maybe it was at you reached the top, right? At some point you reached the peak, the 2.4 megabits. Somebody got on your network, downloading a huge file. Now we're back to like 1.5 megabits. As soon as basically the client notices that those 2.4 megabit chunks are taking longer to download than expected, it can then basically, before even before it's too late, it can actually make a decision to then go back down and download a lower bitrate chunk. Because it keeps a buffer, typically a buffer about 20, 30 seconds ahead, it can actually make these decisions in real time before it actually gets into trouble, right? Before your bandwidth goes down so low that it can no longer keep up in real time. So it's a pretty clever mechanism. And this works for both live and on demand. So how does it actually work? Just if you'd like to find out more about smooth streaming in a lot more detail, I encourage you to go to John Bocciaro's session tomorrow about content delivery using IS Media Services. I'm just going to give you like the sort of the high level here. Basically, the way the smooth streaming format is designed, it's not a brand new format, just like the streaming is not a brand new protocol or something. It's really all kind of standards based. So our delivery method is just plain HTTP download, and the file format is actually based on MP4. So it's based on the ISO-based media file format. And the way it's encoded actually as one long file where essentially each GOP, right, so each group of pictures between two keyframes is actually meticulously stored as a fragment within that file. So it's explicitly noted basically where each fragment starts and ends. So that allows the server to virtually chunk up this file. So when a client says, can I have this time slice, these 2 seconds between this point and this point, the server can easily look into that long file and figure out where that is and exactly give it basically the byte sequence that corresponds to those video frames. So what are the benefits of smooth streaming? Now, you've seen it today and probably in a few demos, but what are really the benefits of smooth streaming? For content providers, the biggest benefit is that it's cheaper to deploy. Why is it cheaper to deploy? It's cheaper to deploy because you can utilize any generic like HTTP infrastructure out there. Remember, the web was really built for HTTP delivery. So unlike with traditional streaming, where if you want to scale your solution, you need to go and deploy a bunch of specialized servers and specialized proxies and caches. In the case of smooth streaming, you don't need to do anything like that. You basically deploy an origin server, and then the origin server just basically takes advantage of any HTTP cache on the web. This really improves your scalability and your reach. It avoids a lot of last mile congestion issues because if a lot of users are asking for the same content, what's going to happen is that content will get cached much closer to the users. So they're never going to go all the way back to the origin server. And most importantly, if you're a content provider and you're trying to figure out how do I encode my content, well, with smooth streaming, you don't need to guess what your audience can handle. This is the real beauty of it, is that you don't need to go and do some guesswork and analysis of, okay, well, 50% of my audience is, can consume 1.5 megabits or more. You don't need to do any of that. You basically you pick a range. You say, I'm going to encode my content at, minimum 300K all the way up to 3 megabits per second. And then you provide some bit rates in the middle, and you let the audience actually adapt to your content as opposed to you trying to guess what they're capable of. If you're an end user, what is the benefit for you? So maybe you're just looking at this, okay, what's in it for me? I just want to consume some content. So first of all, you saw that like as we seek in smooth streaming videos that you get extremely fast startup and seek times. That's because we always seek to the lowest bit rate, and that gives us these like nearly instantaneous seek times. Really the goal of smooth streaming is to provide a smooth experience that has no buffering, no stutter, no disconnects. The idea is not, I want to provide HD quality to everybody, right? That's impossible. You can't do that. If you need 3 megabits per second to encode HD video, then somebody who doesn't have 3 megabits is not going to be able to consume it. But what you can do is you can provide them with the same level of user experience, where it's seamless video, it plays smoothly, it doesn't stutter, they don't need to pause and go and make coffee and come back and then unpause the video and so it can play back smoothly. They basically just always receive the best video they're capable of. And then finally, that's the seamless bitrate switching is a part of that as their network conditions change, it adapts to that as well. So we talked about creation of the application, about encoding of the content. We talked about delivery. The final step is the experience. And the experience today of end-to-end Silverlight media is delivered to a Silverlight runtime. So what are the capabilities of the Silverlight runtime? In Silverlight 2, the media features were primarily based on Windows Media. And then we introduced smooth streaming that works in Silverlight 2 as well. So basically, if you got any Windows Media content, existing Windows Media content, you can deliver that content to Silverlight 2 today. You don't need to go and re-encode that content again. So that continues to work. If you have existing Windows Media-based workflows, there's a very rich Windows Media ecosystem out there. There's a lot of companies that make professional encoders, for example. Some of you are here in the audience today. So if you have basically a Windows Media-based solution that can encode VC1 video, WMA audio, that continues to work. You can deliver that to Silverlight 2 using Windows Media Services if you're doing traditional streaming, or IIS7 or any other web server if you're doing progressive download. It also supports smooth streaming. All those demos that we saw of smooth streaming today, that all works in Silverlight 2 already. You don't need to actually have Silverlight 3 for that to work. And that's delivered using, like we said, HTTP-based adaptive streaming from IIS7. There's other features in Silverlight 2 related to media, such as Silverlight DRM. So if you're interested in doing content protection and really monetizing on that content that you're delivering, protecting it, then Silverlight DRM is there. It's powered by Play-Ready DRM technology by Microsoft, and it's a solution that's already readily available for Silverlight 2. Now, what about Silverlight 3? We're here to talk about Silverlight 3. So let's have a look at Silverlight 3 media features and what they actually bring to the table. So one of the big ones is Silverlight 3 will support H.264 and AAC video decode. I'm sorry, H.264 video and AAC audio decode and MP4 file playback. Another great feature coming in Silverlight 3 is extensible media format support. So if you have, for example, a media format that you love, Ogvorbis, for example, or whatever it is, and you wanted to play it back in Silverlight, you can now go and actually develop your own custom decoders and deploy them with your Silverlight application. Another cool feature of Silverlight 3 related to media is GPU-accelerated video scaling. So this basically means that if you're scaling your video, say, from like windowed mode to full screen mode, there's no additional overhead on the CPU. So if you can play back a certain resolution of video in window mode, and now you want to scale it back to a full screen monitor and whatever the resolution is, no additional overhead on the CPU. That's all being done on the GPU in Silverlight if you choose to do so in Silverlight 3. There's some features going into the Silverlight 3 graphics engine that a lot of people might not consider necessarily media or video features, but they can be applied to media. And so one of them, for example, is the support for pixel shaders, the ability to actually generate custom effects for video. If you went to the keynote today, you saw Scott Guthrie's gratuitous graphics demo, where he showed, how you can really go crazy with these effects and do things to video that don't really make sense. But there are things you can do to the video that make sense. For example, if you want to let the users control the color balance in the video and for example modify the contrast and brightness, you can actually do that using pixel shaders, or turn the video black and white, or add fake grain to the video to make it more cinematic looking like. So there's cool things, there's cool effects you can do with pixel shaders. And then another feature that's not necessarily just video related, it's really just a graphics engine feature, is this perspective 3D, the ability to actually take, for example, your video and now rotate it around 3 axes, so your XYZ axis. And then I should also mention that in the Silverlight 3 timeframe, we'll have broad support coming up for encoding to the smooth streaming format. So right now, today, there's Expression Encoder 2 that can encode to the smooth streaming on-demand format. But we have a number of independent software vendors that we're working with that produce professional-grade encoders who will be supporting encoding to smooth streaming for both on-demand and live. And I would expect that this to be available sometime in the Silverlight 3 timeframe as well. So I mentioned earlier Silverlight is going to support H.264 and AAC decoding. I'll just give you like a few more details about that. Basically, the easiest way to deploy H.264 and AAC is going to be using progressive download from MP4 files. So if you have existing libraries of MP4 content today that are H.264 AAC encoded and fit these profiles, you're good to go. You're going to be able to just basically put them up on a web server and have them downloaded progressively to Silverlight 3 client. I mentioned also format extensibility. So this allows developers to go write custom decoders. So if you have any media format that you're a fan of or that you need to use for whatever reason, either you can go ahead and develop decoders for that, or you can go and contract a third party to go develop that for you. The cool thing about this is that this is code that's written in .NET, so it's safe to run. And it's actually very easy to deliver because it's being delivered as a part of the Silverlight application. So it's completely transparent to the users. So unlike, say, like Windows Media Player, where for a new codec you need to go and run some install and do all that stuff that puts native code in your computer and does God knows what. No, here you can basically deploy brand new codecs with the Silverlight application to the user's machine, runs completely safely, and runs completely transparently to the user. Another cool feature actually that could be done with this is video audio synthesis. So you can actually write like a little video, not video, but like an audio synthesizer, for example, like a MIDI synthesizer using this same feature, the raw AV support. All right, so at the very beginning, I showed you 3 demos. As you recall, we started out by looking at the easiest one. We looked at the Expression Encoder 2. And then the second demo that I showed you was the CTV website. So with the CTV website, basically, you saw that they were delivering smooth streaming content using Player. There was some ad delivery, ad pre-roll, followed by the main feature. It was a pretty simple experience, right? But let's take a deeper look at basically how they actually went and accomplished that workflow. So they started out, and I should actually note that in the case of the Expression Encoder 2 templates, we saw the player experience really kind of bundled together, whereas on the other hand, you can look at the player experience as being actually 2 parts. One being the UI, the skin, right, that determines the look and feel, really the look of the application. And then you can look at the other part of the player experience being the actual media player engine. It determines what media core functionality that has. So what CTV did is they actually treated these 2 parts separately, right? So they actually designed the UI separately from the media player engine. The way they designed the UI is they started out by doing some UI mockups in Photoshop, for example. And then they took those mockups and then they basically took Expression Blend 2 and built a Silverlight XAML UI based on the mockups that they just designed. Then they took those mockups and they merged them together with the Open Video Player media engine. So the Open Video Player framework is this open source community project started by Akamai, where they essentially provide this great out-of-box player experience for Silverlight. It's kind of similar to what we saw with Expression Encoder, where you get this out-of-box great experience. You have all these cool features you would expect from a media player. The Open Video Player does kind of the same thing, does it probably even better because they also built a lot on top of it. But what CTV did is they took the media player, the media engine functionality, and then basically took the UI that they built in Blend and put that on top of the media player engine. As far as content creation goes, their workflow was slightly more complex than we saw in the first example. So most of their content came in on HD cam tapes. And because they came in on tapes and it was a very high quantity, the easiest way to actually sort of export that to a file-based format was by dubbing it onto XD Cam, which uses disk storage. So then they were able to actually copy directly those videos from the XD Cams in MXF format directly to their nonlinear video editors, do some editing, some pre-processing, whatever they needed to do, exported those as just 1280 by 720 MPEG-2 files, and then imported those MPEG-2 files into the Expression Encoder and encoded to the smooth streaming format. And the reason why they used 1280 by 720 is because that was the highest resolution that their smooth streaming export format was to support. So it's a slightly more complex workflow, but as you can see, it's actually still built on top of Expression Encoder. So like I said, this is slightly more advanced example than the first one. What we're seeing is basically the same components, but with additional customization on top. They actually used, they did some level of automation for the encoding. So they used Expression Encoder 2. They used it in command line mode, where they were able to just invoke it from the command line, write some batch files, and let those batch jobs just run overnight. For each video asset, they actually produced 6 bit rates, ranging all the way up to, I believe, 2.5 megabits for 720p video. And they encoded these on the 8-core workstations. They were able to actually give them about 4x real-time turnaround time, which means that about like an hour of video took about 4 hours to encode. Now, that might seem like a long time, but keep in mind, they're encoding to 6 different bit rates. So it's actually 6 different encoding jobs going on for each hour of video. So it's actually, this is a really good turnaround time for that particular, for the smooth streaming format. So finally, the last step that they used, of course, was the publishing, and how do you push the content out to the web? So the actual media content was uploaded to the Akamai CDN just over plain FTP. But to actually let the player know what content is available, they actually used, so they used a proprietary CMS system they developed in-house called Pipe. And in Pipe, they started out by basically tagging the content with different metadata related to publishing, such as when it needs to go live and such. And then they pushed out the content out to the Silverlight players using RSS feeds. And they used a particular extension of the RSS format called Media RSS. This is a format that was originally designed by Yahoo. But they used this Media RSS format as a way of basically directly letting, publishing the content directly to the client, so the client knows as the content becomes available. So if we go back and look at the Silverlight media ecosystem that we had in the beginning we had Expression Encoder as our first step that took care of both the application creation and the content encoding. But in the workflow that CTV adopted, they used Expression Encoder for the encoding, and they used Windows Media Service, IS7 for the actual content delivery, Silverlight for the actual consumption. And then the part they added was the additional customization of that workflow, where they added basic Expression Blend to design the UI, and then the Visual Studio to actually write additional code for the player logic as well. So it's a slightly more enhanced workflow. So the third final example that we're going to look at, the third demo, I'm actually going to go back to the demo and show you that demo again, just in a little bit more detail, just to refresh your memory. Okay. So once again, this is the Accenture Business TV website. And we're going to go load one of these videos. Now, as this video plays, oh, I'm sorry. There we go. Sorry about that. All right. So this is the Accenture Business TV website, and we're going to go load one of these videos. Now, I showed you earlier, there's this cool, rich timeline that they designed where basically they have tags and markers, basically chapter marks embedded into the timeline. So that's pretty cool, but there's another really cool feature of this website is that as this video is playing, you see that there's this presentation, this essential slide deck, that's actually running in sync with the video. So as the video goes on, these slides advance to represent whatever the person in the video is talking about. So I'm going to just pause the video for a second. And the other cool feature of this is that they integrate a deep zoom with the slide show presentation. So I can actually go and zoom into any of these slides to get additional detail about it. Now, in this case, I actually paused the video, but there's another way to do this. I can actually unlink the slide presentation from the video so that it's not advancing in sync with the video. So I can go and zoom into any part of the slide deck. And I'm going to link it up again. And let's say that I want to, I don't care so much about the video. It's just somebody talking, right? Maybe I don't really care about how they're delivering the message. I just want to hear the message, but I want to look at the slides. And so there's a full screen feature that actually puts the slides in the full screen and takes the video and puts it in a picture-in-picture view. We can actually do the exact same thing in reverse. So let me see. I need to go back. Sorry, I just lost my view. Let me do that again. And so we can do the same thing in reverse, where we send the video to full screen, and then we send the actual slide deck up there. And you notice that even though when it's picture-in-picture, we can still do the deep zoom functionality. So that's pretty cool. So let's take a look at what workflow they use to accomplish this whole website here. So they started out with the player design development, which was similar to the way we've seen it before, except, so they started out with UI mockups, right? They started out with just they work with a creative agency called Schematic to actually design and create the UI mockups first. Once they had the mockups, then Schematic went and used Expression Blend to build the actual real XAML UI for Silverlight. But not only did they build the UI, in this particular case, they actually went and implemented all the media player functionality from scratch. So they built the ground up. So they just used Visual Studio 2008, C# to actually build up all the media player functionality. So there was no out-of-box experience that they used as a base player and went from there. They really just kind of started with nothing and then built the ground up. Once they had the player experience, then the second step was content creation. For the video transcoding step, they actually have their own, so Origin Digital has their in-house service called Adapter, which they use to basically capture, encode, transcode media content, and also to do rich media management, and basically it's also a CMS system as well. So this video transcoding system they have can ingest video in a variety of formats and then output it to whatever they need to actually output it to. In this case, they output it to smooth streaming, and they actually use the Expression Encoder SDK. They call into Expression Encoder SDK to create the smooth streaming assets. So a cool feature of that website that you saw was the actual synchronization of the slides to the video. How did they do that? So they started out by inserting some timestamps into the videos. In the case of live streams, they actually inserted them into the streams themselves using script commands. In the case of on-demand content, they just used XML to write down where the timestamps are in the video. And then for the slides, they took the PowerPoint decks and they exported them to bitmaps, so basically just a bunch of JPEGs. And then they took the bitmaps and imported that into the Deep Zoom Composer. This is a tool that you use to create Deep Zoom compositions. You can download it for free today. You can go to the Silverlight.net website and download Deep Zoom Composer. But basically, Origin Digital used these exported bitmaps from the presentation, imported into Deep Zoom Composer, created Deep Zoom presentations. And then they tagged each slide also in the presentation. They created an XML and tagged each slide with the appropriate page number and when it actually should show up in the video. So once they had basically the timestamps on the video side and the timestamps on the deck side, it was easy to actually sync them up together. And then finally, for the publishing step, they used their adapter system also to do the publishing. They were able to edit metadata, create playlists, do all that, and then push that out to the CDN, push the content out to Akamai via FTP, and then actually publish the playlists and the content itself to the website directly from Adapter. So this is, I would say, a most advanced version of the workflow that we saw because they didn't start with any base player or out-of-the-box experience. They essentially started with nothing, created some mockups, created some player UI in Blend, wrote some code in Visual Studio, had their own transcoding system, and finally just published using, once again, their own CMS system as well. So this would be the most advanced example of end-to-end Silverlight media workflow. So that would be the end of our presentation here today. I really highly encourage you to go and check out some of these other sessions that we have, which are really more deep dive type of sessions. The next one up is James Clark's session today at 4 o'clock, where he's going to be talking about content creation using Expression Encoder and also UX creation using Visual Studio and Expression Encoder. So that session is in this room at 4 o'clock, so I encourage you to check that out. Tomorrow, John Bocciaro will be talking about content delivery using IIS Media Services. And then finally on Friday, Nick Brookins will be talking about ad delivery to Silverlight media clients. I encourage you to go and try all these different technologies that I mentioned today. So definitely Silverlight 3 beta. If you haven't installed it already, go install that. Expression Studio has Expression Blend and Expression Encoder as a part of it. So you can go online and actually download trial versions of all these things. And then finally, if you're in the content delivery business and you want to try smooth streaming, IIS Media Services is available today. Smooth streaming is available in beta form. You can download it and try it out. It's great. And finally, my blog, subscribe to it, and that way you'll know about any updates that we have in the Silverlight media space. So with that, I thank you for coming, and I hope you got a lot of useful things out of this presentation. And now we'll open up the Q&A session, so if you have any questions, we'll start with the gentleman over there. Yes?
I don't have a question, I have a statement.
Okay.
I've got learn.com.
Yes. Mm-hmm.
It also has quizzes, polls, surveys, supervisors, PowerPoint.
Yes.
It allows you to do video mashup. So technology is great. It allows you to do video mashup, so you can combine different video and audio outputs.
Yeah, that's great. And that's done using Silverlight?
Right. All Silverlight. You can visit it right now.
Okay. That's great. Thanks. All right. Was there a question? I saw somewhere over there. Yeah, go ahead. Mm-hmm. Yes.
What it feels like is just, an same intelligent feature that, ISM already has. So maybe you can highlight the difference into...
Yes, absolutely. Yeah. So just to repeat the question is what is the difference, again, between bitrate throttling and smooth streaming. So bitrate throttling is really a cost-saving feature for the content providers because it essentially controls the bandwidth being used for delivery of content using progressive download. And you can look at it as a way to enhance existing progressive download scenarios. So for example, if today you have an IIS website, a website or content delivery service running on IIS that's delivering media to clients using a progressive download, this is a way that you can now control the cost, right? Control the bandwidth at which it's being delivered to. Because there's that problem that I mentioned earlier that ordinarily, like if you don't have bitrate throttling, web servers will send content to the client as fast as they can, as fast as the network bandwidth will allow. So that can waste bits if the client's not actually watching the whole thing. So bitrate throttling lets you basically say, I only want to deliver this content at whatever the encoded bitrate is. And so cost-saving feature, right? Look at it as a way to enhance existing progressive download scenarios. With smooth streaming, the goal there is to provide a consistent user playback experience. And we do that first by encoding the content of actually multiple bit rates, delivering it over HTTP and utilizing existing caches for scalability, and then on the client side, switching between the different bit rates dynamically to actually adapt the video quality to the quality of the network connection and the CPU capabilities of the client. So it's really an end-to-end solution that not only solves the cost issue or the delivery issues, but it also tackles that last mile congestion problem. It really improves the scalability of the solution, and it really, really improves the user experience on the client side. Silverlight streaming services. Silverlight streaming services don't support smooth streaming just yet. So I don't know what their plans are, but right now they don't support it. Yes, go ahead. Great question. Yeah. So the question is, when you encode to smooth streaming format, do you get multiple files or do you get like a single file as the output? The output is one file per bit rate. So if you're encoding your video to 6 different bit rates, you get 6 different files as output. And each file has the different video bit rate. The audio track typically gets multiplexed with one of those files. So the audio track's not repeated in each file. It's usually just in one of the files.
So is it the IIS plugin then that is determining which pieces or which files the clients can...
Exactly, yeah. There's a server-side manifest, which is just an XML basically doc that also gets created during the content creation. And based on that XML manifest, the server goes and figures out which file has which bit rate, so that when the client requests a certain bit rate in a certain time segment, the server knows where to actually look for it. Yeah. Yeah, the client doesn't care which file the actual, each bit rate is in. The client is only really asking for an asset. It's saying, give me this asset at this bit rate at this time slice. And then the server goes and figures out where it's physically located and where in the file that time segment is. Actually, I think his hand was up first. Go ahead.
In the case of the origin server, stream, what happens to the player? What kind of error correction happens?
So in the case of where, for example, let's say that there's 6 encoded bit rates, and then the player is asking for example, the highest bit rate, and for some reason it's not getting those chunks back from the server, it can then actually, it's smart enough to go and request an alternative chunk. So it can actually ask for a fragment at a lower bit rate, for example. Now, what happens if the origin server goes entirely down? Well, you would need to make sure on the server backend, obviously, you have some redundancy solution in place that's goes beyond the scope of just smooth streaming. But hopefully, some of those chunks, some of those fragments got actually cached closer to the user. So even if the origin server goes down, maybe they can still actually grab it from the cache. And you had a question? Yes, go ahead.
What about live smooth streaming?
Live smooth streaming. So live smooth streaming, we're also announcing today as a part of IS Media Services, at least the server component. The beta is available now for download, and there's a simulator program that comes when you download the beta that actually lets you simulate like a live encoding process, so you can see how that works. When it comes to deployment, if the question is how soon will you be able to deploy a live smooth streaming solution, the answer is once the encoding vendors actually have live encoders able to produce the smooth streaming output format. Because right now, obviously, we have the server piece, but you need the encoder piece as well. And we're working with a number of encoding vendors that we worked in the past. They're old Windows Media partners of ours. But we're working with a number of encoding vendors right now on enabling them to support the smooth streaming format, both for live and for on-demand. So as soon as the first vendor comes out with a live smooth streaming encoder, the server piece, the beta is already out there. At that point, you'll be able to actually test this end-to-end and then go and deploy it. Go ahead in the back over there. Yes, it is. Great question. The question is play-ready protection support in smooth streaming? And the answer is yes. They'll have to also stress that the dependency in this case will also once again be on the encoding vendors, because typically in the workflow that includes content protection, the protection is applied at the encoding time. So once the vendors actually implement play-ready encryption in their products, then it's going to be supported end-to-end, yeah. Go ahead. Well, the question is, will Windows Media Services provide statistics about bandwidth usage? There's no plans for it right now. I mean, Windows Media Services right now is really kind of engineered to provide, single bitrate traditional streaming. Really for scalability, if you really want large scalability, my advice is to start looking at smooth streaming and IS7 media services. That's really the way to go. Was your question about IS7 media services, or was it about like Windows Media Services, traditional ones? Okay, so you're asking about IIS. So in the case of IIS, I'm not sure I know the answer to that, but that would be a great question to ask John Bocharo when he delivers as a content delivery session tomorrow. Yeah, so with Silverlight 3 and with IS Media Services, logging is supported. It's a part of the solution. So Silverlight 3 client, for example, supports logging back to the server for media usage, and then the IS7 Media Services support actual reception of these client logging statistics. So yes, you will be able to actually develop a logging solution based on that. But it is a great question. So if you're going to go to tomorrow's session about content delivery, it would be a great question to ask then as well. I think you'll be able to get a more detailed answer tomorrow. Hold on, there was somebody I think over there that had a question. Yes, go ahead. Okay, yeah, so the question is there any solution for doing batch encoding using expression encoder? Yes, the answer is that yes, there's an SDK of expression encoder available now, so you can download that and you can build your own solutions based on expression encoder. You can embed that into your project so you can completely automate the workflow. So the simplest way to automate workflow, you can call expression encoder from the command line, but if you really want to go completely in-depth, full integration, there's an SDK available online. You can download and use that. All right, in the back again. Yes. You can look at it in a way, yeah. Yeah, so that's another great question. Yeah, so we are actually providing what we're calling the smooth streaming encoder SDK and smooth streaming container SDK. Right now, we're just providing it to the encoder ISVs at this point, so they can enable the support in their products. But we're looking at potential options for perhaps even providing that publicly in a much more accessible way in the future. Okay, come talk to me after the session, and then we can talk about that more. But yeah, so. Yeah, sorry. More questions? Yes, question right there. Go ahead. If the Silverlight, okay, so the question is, will smooth streaming work on Silverlight deployed to an Apache server? Is that right? So if your Silverlight application is running off an Apache server, then sure, it can work. The important part is that the media itself is being delivered from an IIS-7 server. So smooth streaming is an extension for IIS-7. So the actual media, the content needs to be delivered from an IIS server. But the application itself, the Silverlight application, can run on an Apache server just fine. So you can actually, you can mix the two together. All right, additional questions? We have about, I think, a few minutes left. So, sorry. I'm having trouble seeing hands, a lot of lights in my face. Right, sorry, go ahead, yeah. Okay, yeah, the question is there any plans for support of RTSP protocol in the future Silverlight versions? We're looking at that option. To be quite honest with you, there hasn't been a lot of demand for RTSP support so far in Silverlight. Largely because most developers and most content providers seem to be pretty happy with HTTP delivery, whether it's Windows Media Services HTTP or regular HTTP download. But so far there hasn't been a lot of requests for RTSP. We're looking at it. It might come in future Silverlight versions, but we're betting on smooth streaming. We're really betting that that's going to revolutionize media delivery on the web. Go ahead. I'm sorry, can you repeat the question? Okay. Okay, I see. Okay, yeah. So for the offline scenarios, right now your choices are basically to store the media and isolate the storage. But we're also investigating, how can we perhaps give access to the file system while still keeping it secure. So there might be news on that front for the final version of Silverlight. But currently in Silverlight 3 beta, you can only store the media on isolated storage for offline scenarios. But that might change. Go ahead. So it's the only mechanism natively supported in Silverlight. Well, let me rephrase that. Player-ready DRM is what you need to have a player-ready license server to deliver the licenses to actually be able to decrypt the content. The actual encryption used, it can be either player-ready AES encryption or Windows Media 10 DRM encryption. So if you have old content that's already encrypted using Windows Media DRM, you can actually consume that content in Silverlight, even in Silverlight 2 already. You just need to make sure that you set up a player-ready license server to deliver the new type of licenses. But the content itself doesn't need to be re-encrypted or re-encoded. Go ahead. So the question is there any features in Silverlight to do webcam or microphone capture? They're not yet in Silverlight 3. It's another area that we're investigating. If you want to contact me after the session or offline, I can probably put you in touch with some of the folks at Microsoft who are basically planning these features, so you might be able to get better answers from them. There was a session earlier today to talk about Silverlight 3 features by Joe Stegman. He's actually probably a good contact to ask him about that as well, and if you went to that session or not. Any more hands up? No? All right. Okay, one more. Just one more. Yes. Yeah. Mm-hmm. So the question is, does the caching either happen in IIS or can it happen in any generic cache? Yes, yes. For smooth streaming, you can use any generic HTTP cache on the web. It doesn't need to be IIS-based. It can be Linux-based. It can be a standalone hardware device. Any HTTP cache that's able to basically cache an HTTP request and cache the files on itself will work. So that's really like why it's such a scalable solution, is because you basically set up an origin server that can do smooth streaming. That's an IIS-7 server. But the rest of your infrastructure, you just take advantage of what's out there. And that's the difference between smooth streaming and traditional streaming, where you have to go and build out the infrastructure. So as I like to say, the difference is that previously we were trying to adapt the web to our streaming protocols, and now we built a streaming protocol that really just adapts to the web. All right. Well, I thank you all for coming. If you have any additional questions, I'll be around, so feel free to stop by and ask me in person. But thank you for coming, and I hope you got a lot of useful information out of the session today. Thanks.